Their paper, known today as EPR, argued that the equations of quantum mechanics predicted an impossible connection between particles, a seemingly magical effect. Quantum theory suggested this effect could happen in the real world, for example with particles of light, photons. The equations implied that a source of photons could create pairs in such a way that when we measure one, causing it to snap out of its fuzzy state, the other mysteriously snaps out of its own fuzzy state at the same instant, with correlated properties. How could two particles act in unison, even when they're separated from each other?
Essential to the EPR argument is that these particles can be separated at an arbitrary distance. And yet, according to quantum mechanics, a choice to measure something here is somehow instantaneously affecting what could be said about this other particle.
Quantum particles acting in unison could be explained if they were communicating. One particle instantly sending a signal to the other, telling it what properties it should have. But that would require a signal traveling faster than the speed of light, something Einstein's theory of special relativity had proven impossible. And it would mean the particles were fuzzy and undefined until the moment they were observed. When Niels Bohr heard of Einstein's paper, he wrote in a response, arguing that one particle could instantly influence another. This seemingly impossible phenomena became known as quantum entanglement. But Einstein dismissed it as spooky action at a distance. John Clauser and Stuart Friedman constructed the world's first Bell test experiment. They focused a laser onto calcium atoms, creating pairs of photons that the equations of quantum theory suggested should be entangled. They recorded whether or not the photons passed through polarization filters on each side, and checked how often the answers agreed. After thousands of pairs, if the results were more correlated than Einstein's physics predicted, the photons must be spookily entangled. The outcome was exactly what Bohr's quantum mechanics predicted. The experiment appeared to show that the spooky connections of quantum entanglement did exist in the natural world.